Hello friends. Now again we are going to discuss the previous year's questions. Uh, the remaining two questions of 2021 that are very important. In fact, the question is briefly mention the alignment of major mountain ranges of world and explain their impact on local weather conditions with examples. कौन सी मेजर माउंटेन रेंजेस हैं वर्ल्ड में, अलाइनमेंट क्या है उनका, mention the alignment of major mountain ranges and discuss their impact, explain their impact on local weather conditions. अब देखो, there are certain mountain ranges like Rockies mountain that run north south in North America. On the western margins of North America, Rockies mountain are there. Then Andes mountain run along western margins of this South America. Then Himalayan range that separates Indian subcontinent from rest of the Asia, or that acts as boundary between India and Tibet. Then Great Dividing Range on the eastern part of this Australia, Great Dividing Range on the eastern part of Australia. Then Jolan mountain that separates Norway from Sweden. World map. And then you have Alps mountain that is spreading over the south central part of Europe in a crescent shape. We'll discuss them. World map. वर्ल्ड मैप कहाँ चला गया, डॉक्यूमेंट्स, वर्ल्ड मैप. See, Rockies mountain runs along the western margin of North America, Andes mountain along the western margin of South America. Then you can see Himalayas runs along the northern part of India, in the northern margins of India. Then Jolan mountains run along the border of Norway and Sweden, Jolan mountains. And then Great Dividing Range on the eastern side of Australia. Numerous ranges, this Alps spread over France, Switzerland, Italy, Liechtenstein, Austria. It is spread over these countries, this Alps. So this is the orientation. You have seen the orientation. Now let us come down to more important part, that is what impact do they have? What impact do they have on the local climate? देखो, if you have your atlas, open your atlas, open up your atlas. तो मुझे तो लोकेशन से याद है, तुम ठीक से देख पाओगे उसको. Let us start with Rockies mountain. Now if you see Rockies mountain, you see these Rockies mountain, they run from Alaska, Canada, USA, Mexico. In Canada, they are spread over British Columbia. It is because of these Rockies mountain that they obstruct the course of westerly winds. Therefore, British Columbia province of Canada receive copious rainfall. इसी रेनफॉल की वजह से यहाँ पर हाइड्रोइलेक्ट्रिक जनरेशन इज वेरी हाई. Therefore, previously the largest aluminum smelting plants were located in British Columbia. बड़े Kitimat scheme and all, because cheap hydroelectricity was there. extraction of aluminum is energy intensive industry. It was found in British Columbia because here the Rockies obstruct the westerly winds, and as a result British Columbia receives copious rainfall. This rainfall also moderates the climate of British Columbia. British Columbia is located in high latitude, isn't it? It is very cold, but moisture always has a moderating impact. As a result, the winters of British Columbia are not so cold, just like in Britain. उसी लैटिट्यूड पे है, एंड सेम वेस्टर्ली विंड्स दैट इफेक्ट ब्रिटेन दैट आल्सो इफेक्ट ब्रिटिश कोलंबिया. इट्स वेदर एग्जैक्टली लाइक Great Britain, like UK. Now British Columbia receives rainfall, and basically it has flourishing smelting industry, aluminum smelting industry. Its weather is moderated by this influence of moisture. But on the leeward side of Rockies, here lies Alberta, Saskatchewan, these provinces. Alberta is located on the leeward side of Rockies Mountain. ये Rockies Mountain है, तो Alberta is completely devoid of the moderating impact of westerly winds. The moisture of westerly winds does not reach on the leeward side. Alberta is located on the leeward side of Rockies Mountain. As a result, it is having continental location. It's away from the eastern coast, and on the west it is blocked by Rockies Mountain. As a result, Alberta is extremely cold, dry, cold and dry. So dry, so cold that wheat cultivation is done only in the southern part. Mostly oat and other crops, hardy crops are grown over here. Now, ranching is used to be the most important occupation previously. अब तो oil निकल आया है बहुत सारा. Alberta is a huge oil producing state of Canada. Alberta में extreme low temperature or basically low rainfall, dry region. This is the impact of Rockies Mountain on Alberta. Now here, as we come down to USA, if you see the open the map of USA, I will show you. In USA, basically, open the map of USA. Here you find wind. जैसे winds Rockies Mountain में ascend करेंगे, they will cause rainfall. In western part of USA, because of this mountainous, multiple ranges are there. Coastal range, Sierra Nevada range, a number of ranges are there. As a result of these ranges, the moisture does not reach these areas. The southwestern part of USA is a big desert. Southwestern part of USA is a big desert. Like New Mexico, Arizona, Nevada, Utah, these are deserts. Because of range and valley topography, moderating impact of rainfall is absent. Now, after ascending the mountain, in Montana and Wyoming province, these winds descend down the Rocky Mountain. Those winds are known as Chinook. As the winds descend down the Rockies Mountain in the provinces of Montana in north, and Montana, and to the south is Wyoming. Winds descend down. Chinook, as they descend down, they get adiabatically heated. They become warm and dry. They become very warm and dry. These Chinook winds are found to be blowing in Montana, Wyoming, and Colorado province. As they descend down, they are so warm and dry that they have registered an increase in temperature by 22 degree in 24 hours. There's a place Kip in Montana, Montana is a very cold province. इतनी warm and dry winds होती हैं Chinook कि they registered an increase of temperature of 22 degree in 24 hours. They are so dry that they evaporate the snow lying on the surface. जितनी भी winters में snow होती है वो सबको evaporate कर देती है. Therefore, these winds are very much welcomed by the ranchers because grasslands are kept free from snow, so ranching can be done. But at the same time, because of evaporation of the snow, the melt water is not available in spring season. That hampers agriculture, although it is beneficial for local ranchers. So these winds are warm and dry, and they blow in winters. So basically, these winds are so dry, they keep एक जगह है डेनेवर कोलोराडो में, डेनेवर टेम्परेचर इंक्रीज बाय 14 डिग्री बिकॉज ऑफ द चीनूक विंड्स, टेम्परेचर इंक्रीज बाय 14 डिग्री इन 2 आवर्स। और बेसिकली देयर इज अ प्लेस की मोन्टाना में, तो हम मोन्टाना कीप में 7 मिनट में टेम्परेचर इंक्रीज बाय 19 डिग्रीज। बेसिकली कीप में 22 डिग्री, दिस वाज समवेयर एल्स इन मोन्टाना। इन वहाँ कीप में जो टेम्परेचर इंक्रीज किया था, विद इन 7 मिनट्स टेम्परेचर इंक्रीज बाय 19 डिग्री। सो चीनूक winds are very warm and very dry. It is due to the occasional onslaught of these winds that the severity of winters in the western part of Great Plains is prevented. मतलब ये winds इतनी वार्म होती हैं कि एक्सट्रीम विंटर्स में ब्लो करती हैं और वहाँ की विंटर्स को बहुत मॉडरेट कर देती हैं. Because of occasional onslaught of these warm and dry winds, that the severity of winters in the western part of Great Plains is reduced. ऐसे ही in southern part of USA, in the winds descend down the mountains in southern California valley. These are known as Santa Ana, Santa-Ana. Santa Ana, again, they are the result of descending winds from the adjoining mountains. They are found to be blowing in southern California. These winds, because of descending and basically they get adiabatically heated, they are also very warm and dry. And they are so warm and dry that they cause forest fires. Trees dry up under the impact. California में जो citrus fruits के orchards हैं, they get destroyed. Trees get dried up. Large scale fires. Sometimes these Santana winds are laden with so much dust that breathing becomes difficult. Now next, let us come on to Andes. This is Andes mountain. Now you see on the western side of Andes, here we have Atacama Desert. One thing must be clear, Andes mountain has nothing to do with Atacama Desert. Andes ना भी होते तो भी यहाँ Atacama Desert होता, because Atacama Desert is because of offshore trade winds found in this region. Atacama Desert is desert because of offshore trade winds. Andes नहीं भी होते तो भी वो desert होता. हाँ, in the southern part, here, this Patagonia plateau is a desert because it lies on the leeward side of westerly winds. Westerly winds blowing here, their moisture is precipitated by Andes range, and on the leeward side, when they descend down, they are devoid of moisture. At Patagonia desert is a desert because of rain shadow effect of Andes mountain. Moreover, in the central part, on the eastern slopes of Andes, another wind descends down, that is Zonda. Zonda flows in the plains, Pampas region of Argentina. Zonda is also descending down from the Andes mountain on the eastern slopes. So it is also very warm and dry wind. Blows down the eastern slopes of Andes in the plains of Argentina. These trigger wildfire because they are very warm and affect human health. Zonda winds are known for their high speed and they raise the temperature of the region by 40 degree centigrade. Now you can see this is Alps mountain. Switzerland lies along the northern slopes of Alps. Switzerland is a cold country. Now along the northern slopes of Alps, basically Foehn, F-O-E-H-N, Foehn winds blows along the northern slopes of Alps through Switzerland. Because of descent, these winds descend down the slope, so they get adiabatically heated. So these winds are warm and dry, and these winds cause avalanches. They are found to be causing avalanches. They have caused avalanches in Switzerland. ये कहीं mention नहीं, avalanches. And these Foehn winds are found to be blowing during spring and early winter. Their arrival is marked by rapid rise in temperature. They cause avalanches and melting of glacier. Although in winter, because they evaporate the snow, they melt the snow. So they are helpful for spring farming. And on the southern slopes of Alps, Bora winds descend down the Adriatic Sea and to the Lombardy plains of Italy. Now here Himalayas. Jolan Mountains, very important. Like the way westerlies are blowing in British Columbia, causing rainfall because of this Rockies mountain, the same way the westerlies cause heavy rainfall along the coast of Norway. Westerlies cause heavy rainfall along the coast of Norway. Therefore, Norway is the world's largest hydro per capita hydroelectricity generating country. And aluminum smelting plants are also Trondheim. Trondheim is famous for aluminum smelting. Aluminum smelting plants are located here at several places. Norway's climate is also moderated by this warm moderating impact of sea breeze because of westerlies. It is very moderate despite being located at a high latitude. Because of moderating impact of moisture caused by westerly winds, its temperature is found to be is moderated by these winds. But the on the leeward side, Sweden lies on the leeward side. So this moderating impact of wind is absent because of rain shadow effect of Julan mountain. Sweden is extremely cold, so cold that this Gulf of Bothnia remains frozen throughout the year. Sweden is devoid of this moderating impact because of this Julan mountain. And here in Sweden, because absence of moisture, it becomes extremely cold. Agriculture is confined to the southern part of Sweden. Skane farms, southern part of Sweden. In northern part, this Gulf of Bothnia itself remains frozen for most part of winters. Impact of local mountain, Himalayas. Basically, Himalayas play a very important role. They not only protect the India from the cold, icy Siberian winds, they also direct the monsoon Bay of Bengal branch along the northern plains, which causes rainfall from east to west. Himalayas are found to be, they are responsible for determining the date of monsoon burst, and they also direct the orientation of Bay of Bengal branch, which from Bay of Bengal it turns towards its left against the Ferrell's law, and causes blows from, because of orientation of Himalaya, blows from east to west, known as Purvaya in northern plains, and it causes rainfall, bulk of the rainfall in this region. So this is how basically these great dividing range alignment and the impact that they have on the local weather. Now very important question जो कि यूपीएससी में जीएस में पूछा गया था कि हाउ डज द मेल्टिंग ऑफ आर्कटिक आइस एंड द मेल्टिंग ऑफ अंटार्कटिक ग्लेशियर हैव डिफरेंट impacts on weather and human activities. दिस क्वेश्चन जिसने नहीं पढ़ा होगा वो तो टच भी नहीं कर सकता. मतलब कैसे मेल्टिंग ऑफ आर्कटिक आइस and melting of Antarctic glacier are having different impacts in global weather pattern as well as human activities. Now let us see. See, melting of Arctic ice. So Arctic ice kya hai? This region, Arctic, this here, this Arctic ice. Antarctic continent is on the southern hemisphere, huge continent. You can see this, largely covered by ice. Average thickness of ice on Antarctica is 2.5 किलोमीटर. कैसे आर्कटिक आइस और अंटार्कटिक आइस के मेल्ट होने का इंपैक्ट डिफरेंट होता है ग्लोबल वेदर पे और ह्यूमन एक्टिविटीज पे. बेसिकली आर्कटिक आइस और अंटार्कटिक ग्लेशियर्स आर मेल्टिंग बिकॉज ऑफ ग्लोबल वार्मिंग, and that is supposed to be because of burning of fossil fuels by human activities. Now let us see how do they impact differently on global weather. How do the melting of Arctic ice and glaciers of Antarctica differently affect the weather patterns and human activities on Earth? Now, कैसे अलग अलग तरीके से impact करते हैं? See, first, impact of melting of Arctic ice. See, you might have studied about the wind pattern. This is subpolar low pressure belt. Polar easterlies blow east to west to the north of it, and westerlies blow from west to east to the south of it. These are cold polar easterlies emanating from Arctic region, and these are warm westerlies coming from subtropical high pressure belt. These winds are extremely cold because they come from ice frozen area, and these westerlies are warm because they are the result of sinking of air in subtropical high pressure belt. These are warm winds, these are cold winds. Now, when Arctic ice melts, global warming takes place. The temperature of these cold polar easterlies will decrease, and the temperature contrast between these two air masses will decrease. Basically, there are winds in the upper troposphere known as polar front jet stream. एक winds होती हैं polar front jet stream found in upper atmosphere, very high velocity winds blowing from west to east. These winds are generated because of temperature contrast between between westerlies and polar easterlies. जितना ज़्यादा इनमें temperature contrast होगा, with height the pressure gradient will be steep and strong polar front jet streams will be generated. Winters में क्या होता है? The cold polar easterlies are cold and warm westerlies are warm. Temperature contrast is more and polar front jet stream is very strong. But in summer it is weak, because in summer basically these are not so cold and these are already warm, so the temperature contrast is less, and because of this the polar front jet streams are weak. Now with the melting of Arctic ice, the temperature of these cold polar easterlies will decrease, and these are already warm. The temperature contrast between these two winds will decrease. As a result, the pressure gradient in upper atmosphere will become weak, and weak polar front jet stream will be generated. So पहला impact melting of Arctic ice का है weakening of polar front jet stream. A polar front jet stream, they meander making Rossby waves. They are responsible for the genesis of temperate cyclone, that is the sole mechanism of causing rainfall in middle and high latitudes. अब जब polar front jet stream weak हो जाएंगी, and since these are responsible for the genesis of temperate cyclone, so the frequency and intensity of temperate cyclone will become weak. So the rainfall pattern will become erratic. Weakening melting of Arctic ice will weaken the polar front jet stream, and weakening of polar front jet stream will weaken the frequency and intensity of temperate cyclone. And as that frequency and intensity of temperate cyclone will decrease, rainfall will decrease, rainfall will become erratic, and when rainfall will decrease, the impact of continentality will increase. Extreme long spells of cold season will increase in North America and यूरोप. मतलब रेनफॉल भी डिक्लाइन हो जाएगी और बेसिकली दिस एग्रीकल्चर भी एडवर्सली इंपैक्ट होगा, और कोल्ड स्पेल्स विल इंक्रीज इन नॉर्थ अमेरिका एंड यूरोप. दूसरा, आर्कटिक आइस, बेसिकली जो आइस कवर है, इट प्लेज अ वेरी इंपॉर्टेंट रोल इन रिफ्लेक्टिंग द इनकमिंग सोलर रेडिएशन, दैट इज नोन एज एल्बिडो, and that keeps the area cool, because ice is a good reflector. Large amount of solar insolation that is received by ice covered regions, the Arctic ice, is reflected back to space without playing any role in heating and cooling. So once this Arctic ice melts, this would ensure more and more solar insolation is absorbed in the oceanic water. That will further expedite the warming of Arctic Ocean. This is known as Arctic amplification. जैसे आर्कटिक आइस मेल्ट करेगी तो बेसिकली रिफ्लेक्शन कम हो जाएगा, एब्जॉर्प्शन सोलर इंसुलेशन का बढ़ जाएगा, एंड द टेम्परेचर ऑफ आर्कटिक ओशन विल स्टार्ट इंक्रीजिंग इवन फास्टर. वैसे भी तेजी से बढ़ रहा है. दिस फिनोमेना इज नोन एज आर्कटिक एम्प्लीफिकेशन. दिस विल लीड टू इंक्रीज फ्रीक्वेंसी एंड इंटेंसिटी ऑफ एक्सट्रीम वेदर इवेंट्स. थर्ड एंड मोस्ट इंपॉर्टेंट, एक सर्कुलेशन होता है थर्मोहेलाइन सर्कुलेशन, और इसको हम लोग वी ऑल्सो कॉल इट ग्लोबल कन्वेयर बेल्ट, एंड इट इज ऑल्सो नोन एज अटलांटिक मेरिडियनल ओवरटर्निंग सर्कुलेशन. नाम भारी भरकम है, कॉन्सेप्ट बहुत सीधा सा है. ये बेसिकली जितने भी करंट्स होते हैं ना, जैसे नॉर्थ इक्वेटोरियल करंट, जैसे अटलांटिक ओशन में देखो, फिर इट एंटर्स इनटू कैरेबियन सी, बिकम्स कैरेबियन करंट, देन मूव्स आउट ऑफ स्टेट्स ऑफ फ्लोरिडा, बिकम्स फ्लोरिडा करंट, एंड दिस फ्लोरिडा करंट जॉइंस विद एंटीलीज करंट एंड फॉर्म्स गल्फ स्ट्रीम करंट, एंड गल्फ स्ट्रीम करंट मूव्स नॉर्थवर्ड एंड सिंक्स डाउन. I will discuss sink down. After sinking down, it moves on the ocean bottom as subsurface currents towards equatorial region, where it again upwells. So it is a vertical circulation. Now, this entire is known as global conveyor belt. मोटा मोटी समझा रहा हूं, जैसे surface currents है ना, as the warm saline Gulf Stream moves northward, it comes into contact with extreme cold water. Salinity is already high and temperature भी low हो गया, तो density of current increases, it sinks down, and after sinking down, it moves on the surface of the ocean. As a result of differences in temperature and salinity, it is known as thermohaline current. Moves on the surface very slowly, very slowly. It takes centuries. Then it comes towards the equatorial region where upwelling takes place and upwells over there. ये पूरा सिस्टम को कहते हैं ग्लोबल कन्वेयर बेल्ट. It's a vast system of this thermohaline circulation or global conveyor belt is a vast system of interconnected ocean currents that move water around the entire globe. This system plays a very important role in regulating Earth's climate. अब कैसे क्या क्या? Distributing heat across different latitudinal zones, distributing nutrients in various oceans, and distributing and storing carbon dioxide. It plays a very important role. अगर आर्कटिक आइस मेल्ट हो गई, एक तो पोलर फ्रंट जेट स्ट्रीम वीक हो जाएगी, रेनफॉल कम हो जाएगी, एक्सट्रीम कोल्ड हो जाएगा. दूसरा बेसिकली रीजन बताया, एल्बिडो बढ़ जाएगा, एल्बिडो घट जाएगा, हीट एब्जॉर्ब होगी. तीसरा रीजन है, अगर आर्कटिक आइस मेल्ट हुई, then this entire oceanic circulation will get adversely impacted. Now, अब शुरुआत करते हैं कैसे करंट शुरू होता है. This current, this thermohaline circulation or global conveyor belt or Atlantic meridional overturning circulation, AMOC, starts in the northern part of, this begins in the northern part of Arctic, that is in North Atlantic. The global conveyor belt begins in the polar region, particularly in the North Atlantic Ocean, near Greenland and Iceland. यहाँ पर क्या होता है, because of extreme cold, sea ice gets formed. That is, water freezes. Water freezes. Sea ice gets formed near Iceland and Greenland because of low temperature. And whenever ice gets formed, it always expels the salt brines. अपना नमक बाहर फेंक देती है. Ice always gets frozen slowly and salt brines are expelled. As a result, the water of this high latitude dissolves the salt, and water is already cold, so its density is high. As well as when salt gets dissolved, it becomes even denser, and this salty cold water sinks down on the surface, and on the surface it forms Atlantic, North Atlantic deep water that moves towards equator. As this water sinks down, you must know that 90% of the atmospheric carbon dioxide is absorbed by oceanic water, and bulk of this carbon dioxide is carried down by this sinking water, and it is stored in the ocean bottom for centuries. जब ये sink down करता है ना, on surface it moves very slowly, very slowly. It takes centuries for this current to complete this circulation. The movement of the current on the ocean bottom, that is thermohaline circulation, that is movement takes place because of differences in temperature and salinity. This movement is very slow. When it sinks down because of low temperature and high salinity, it also dissolves atmospheric carbon dioxide and takes it to the bottom and stored there for centuries. And when it moves towards equatorial region, it again upwells. जैसे ये polar region है, ये equatorial region है, this is sea. Here sinking is taking place. Cold saline water sinks down, dissolving carbon dioxide. On the surface, this movement is extremely slow. On the bottom, this is known as thermohaline circulation, because this circulation takes place because of differences in temperature and salinity. And this is very slow movement. It continues to move on the bottom for centuries, and ultimately when it upwells in equatorial region, it brings nutrients along with it, and these nutrients are required by aquatic animals like fishes. So it plays three important roles. The surface current, like Gulf Stream, which is when it moves towards poles, it carries warm saline water, that is, it carries heat towards polar region. Secondly, this current, when it sinks down, it carries down carbon dioxide with it, and again when it upwells, it brings nutrient. Now, when Arctic ice melts, this entire oceanic circulation is adversely impacted. Why? Because when the Arctic ice melt, ये polar region है ना, जब melt करेगी, water जब freeze करता है, then it expels salt brine and makes the cold water saline, so it sinks down. But when the ice starts melting, it adds fresh water. That makes water, when Arctic ice melts, it releases fresh water. It reduces the salinity, it reduces the density, and water does not sink down. And if this water does not sink down, this entire circulation is adversely impacted, impacting the storage of carbon dioxide, impacting the upwelling of nutrient, and transporting the heat to high latitude. This all gets adversely impacted. Now, as this deep water, again surface, but now impact of melting of glaciers of Antarctic. ये तो तीन इफेक्ट थे, impact of melting of Arctic ice. Now we are discussing the impact of melting of Antarctic glacier. भाई देखो, आर्कटिक आइस कहाँ है? आर्कटिक ओशन तो बेसिकली आइस ओशन में ही है ना. आर्कटिक आइस इज फ्लोटिंग ऑन ओशन. अगर ये मेल्ट भी करेगी तो सी लेवल पे कोई चेंज नहीं आएगा. एक ग्लास में एक बर्फ का टुकड़ा डाल दो, वो बर्फ पूरी मेल्ट हो जाएगी, तो ग्लास में वाटर का लेवल नहीं बढ़ेगा, बिकॉज आर्कटिक आइस इटसेल्फ इज फ्लोटिंग ऑन सी. लेकिन अंटार्कटिक इज अ कॉन्टिनेंट एंड देयर इज on an average 2.5 kilometer thick ice cover over Antarctica. If this ice over Antarctica melts, then this ice will raise the global sea level. आर्कटिक आइस के मेल्ट होने से सी लेवल नहीं बढ़ेगा, क्योंकि वो तो वैसे ही पानी में फ्लोट कर रही है. लेकिन अंटार्कटिक इज अ कॉन्टिनेंट जिसपे कि 2.5 किलोमीटर एवरेज थिकनेस आइस की, कहीं कहीं आइस की थिकनेस 5 किलोमीटर है. यहां जब ग्लेशियर्स मेल्ट करेंगे, it will significantly impact on the rise in the sea level, and large number of people living in coastal areas will get adversely impacted. Melting of Antarctic glacier contributes significantly to global sea level rise, posing a major threat to coastal population and ecosystem worldwide. दूसरा इम्पैक्ट आर्कटिक ग्लेशियर अंटार्कटिक ग्लेशियर्स के मेल्ट होने का, मेल्टिंग ऑफ अंटार्कटिक ग्लेशियर्स will increase the influx of fresh water, which will disrupt global circulation pattern and influence El Nino and La Nina. This has been observed by studies. अगर आर्कटिक अंटार्कटिका का ग्लेशियर्स मेल्ट हुए, बिकॉज 75% ऑफ फ्रेश वाटर इज स्टोर्ड इन अंटार्कटिका, so it will increase the influx of fresh water that will adversely impact the global ocean circulation pattern, and it will have adverse impact on El Nino and La Nina. Third, melting of glaciers on Antarctica will affect southern hemisphere storm tracks, जो तूफान आते हैं, and rainfall pattern. अब देखते हैं ह्यूमन एक्टिविटीज पे क्या फर्क पड़ेगा. अगर भाई आर्कटिक आइस मेल्ट करती है तो भाई नेविगेशन का बड़ा शॉर्ट रूट निकल आएगा सीधे आर्कटिक से. तुम देखो, दिस रशिया एंड यूएसए आर वेरी क्लोज टू ईच अदर इन हाई लैटिट्यूड्स, अलास्का एंड साइबेरिया. अगर वहां से रूट निकल आए तो बेरिंग सी क्रॉस करते हुए सीधे उधर चले जाओ. शॉर्ट शिपिंग रूट्स विल बी एक्सपोज्ड. ओशन सी विल बी amenable for mining. So melting of Arctic ice will open up new shipping routes, access to natural resources, but this will also create a challenge of environmental protection. अब जैसे नॉर्दर्न हेमिस्फीयर में जहाँ आर्कटिक आइस है, वहाँ पर नॉर्दर्न मार्जिन पे बहुत सारी एस्किमोज, इनुइट्स, बहुत सारी ट्राइबल्स रहते हैं. एज दिस आइस विल मेल्ट, this will adversely impact the region of inhabitation of those tribal population. Reduced sea will impact the tradition of hunting, fishing and herding practices for Arctic indigenous inhabitants, indigenous population, because वो तो वहीं पर हाई लैप्स हैं, जैसे इनुइट्स हैं, एस्किमोज हैं, युकागिर हैं, बेसिकली ये बेसिकली बहुत सारी ट्राइब्स हैं चुकॉट्स हैं, ये सब वहीं रहते हैं। जैसे आइस मेल्ट होगी, इनका जोन ऑफ स्फीयर कम हो जाएगा, इनका जो जिस एरिया में हंटिंग हर्डिंग या फिशिंग करते हैं वो रीजन विल डिक्रीज. This will be the impact of melting of Arctic ice on human activities. In case of Antarctic ice, Antarctica glaciers, if they melt, भाई देखो उससे सी लेवल तो बढ़ेगा ही, और सी लेवल बढ़ने से स्टॉर्म सर्ज का जो इम्पैक्ट है, सी सर्ज, राइज इन सी लेवल, that will become very severe on coastal communities. Rising sea level will exacerbate the impact of storm surge and coastal flooding, causing damage to coastal community and infrastructure. ये क्वेश्चन बिना तैयार किए कोई लिख ही नहीं सकता. दिस रिक्वायर्स इन डेप्थ स्टडी. ये क्वेश्चन यूपीएससी में जीएस में पूछा था, बट आई डोंट थिंक एनीबडी वुड हैव आंसर्ड एलिगेंट वे, बिकॉज दिस रिक्वायर्स, जिसने पढ़ रखा है वही आंसर दे सकता है, एंड दिस कैन बी हेल्पफुल इन फ्यूचर ऑल्सो. So that was the discussion of year 2021. Now we'll start with the discussion of year 2020 GS paper 1.